Today we're going to be looking at the 4 different factors that affect a computer system's performance, and these kind of all relate to the processor stuff that we were looking at last time. It really just builds on that. So make sure that you've had a look at the videos and you're 100% clued up on that before going ahead with this. So these things all kind of relate to the processor. First one is the number of cores. Now, some of you might already know this. A normal or a regular, I'm making finger quotes, but you can't even see that, so that's stupid. A regular processor has 1 core on its chip. Now I say regular, it's really just old. It's very rare to actually find this nowadays, but we'll put this as our baseline as regular, as a 1-core processor. Now you always hear about multi-core or dual-core, quad-core, all this type of stuff. And the way the computer sees it is each core is effectively another processor which the computer can use. And there's actually a way where you look at your computer's parts, and it will actually come up multiple processors. So if you have a quad-core processor, your computer will effectively think it has 4 processors. The advantage of this is obviously that if you have 4 of them, that you can do 4 different tasks easier. Now, it's not that it's impossible to do 4 different tasks with a single processor. It's just that the control unit and the control bus needs to put all those instructions into an order, whereas with multiple processors, it can kind of have 4 control units putting things into an order, and that's how that means it can kind of do 4 things at once more effectively, and that means obviously quicker without getting stuck. Alternatively, you can actually just focus those cores and all that processing power into just doing one task really well. The disadvantages is more cores you have, the more voltage it's going to use. So you're going to need to get a better power supply, and obviously your electricity bill is going to go up slightly, but it can also be a bit misleading. This isn't really a disadvantage, but it can be misleading when reading about quad core and dual core. It's not exactly like dual core is twice as good as a single core. It's a bit more complicated than that. So I've made this simple diagram that hopefully explains it. So a single core processor, let's say we've got one that is 4 gigahertz, right? And we have a dual core processor that has 2 gigahertz processors. Now this adds up to 4, obviously, so this one would be better for single tasks, but it would struggle multitasking. This one would be better for multitasking, and although it could put its power kind of together, it wouldn't be as good as this one. Now, it's unrealistic that you're going to find a single core 4 gigahertz processor, but obviously if you have a multi-core processor and both of these were 4 gigahertz, that would be better. But just something to bear in mind. Also, there's like some people who are really into building computers could probably say more about this than me. You get like hyper-threaded cores, which are more efficient in that. So it could have a lower speed, but still somehow be faster. But for a general baseline, this is kind of enough to go off on. So the last thing I want to talk about is the clock speed. So just in case you didn't know, this is kind of revision. Maybe I should put this at the start. The clock speed is a pulse generated at a constant rate by the computer. It's measured in hertz, or just, well, it's abbreviated as Hz. And 1 hertz is equal to 1 instruction per second, and then you've got kilohertz, which is 1,000, megahertz, and you've got gigahertz, which is 1 billion. So I've actually put my computer stats up. Now I did this as to show you how misleading it can actually be, because raw numbers. So I've got an octo-core, which means I have 8-core computer, which means I've got 420 billion instructions per second, which sounds insane, but my computer is actually pretty trash. And there's ones that with much lower numbers that are more effective. So it can be a bit misleading, and it can be a bit complicated to actually know what's going on. But one thing that you can do, and this is where it comes into increasing system performance, is overclocking. So if you overclock your computer, it's increasing it up to 1 gigahertz. And there's actually, when your computer boots up, you can, you get that old-fashioned menu coming up, the is it the, I'm going completely blank on what the name is, but when that comes up, you can play out the numbers and just increase it. It will warn you if you want to do that or not, because if you don't know what you're doing, you can break your computer very easily. And that's because there's a lot of reasons. Now, it will make your computer faster, but it can make it a lot warmer as a result. Things can start to melt, things can start to get hot that shouldn't be getting hot, so you'll need to invest in additional fans or maybe water cooling. Obviously, the same way as I mentioned this before, you'll need, if you have a better processor, if you make it go faster with overclocking, you're going to need even more voltage. And this is the weird one. The processor might actually start going so fast that the other parts of the computer that can't keep up with it because they're not designed to keep up with it. That's a bit of a weird one there, but it can happen and it can cause damage. Now, for the next bit, so we've got, this is actually quite a quick one. Data buses, we already covered that. That's the ones that take the data from the processor to RAM. The width of a data bus, this is determined by your word length. Again, we covered this. This is quite an easy one. If you go from 32 bits, a 32-bit data bus to a 64-bit data bus, your computer's productivity, the amount of data it can be transferred at once, is going to increase. So you're going to increase performance. That is honestly an exam question that sometimes comes up. What happens if a 32-bit computer goes from what happens if you upgrade from a 32-bit to a 64-bit computer? And you would say, for 2 marks, the data buses can transfer double the data, and that's 1 mark. And the second mark is just saying, this would increase productivity, and that's it. And there's actually, unlike the others, there's no drawbacks for this one. Cache memory is a tiny piece of memory stored directly on the processor. It's really limited because it's quite expensive to make. Now, it's stored directly on the processor, and because of that, it's the fastest type of memory available. It's actually faster. I think the last PowerPoint said registers were. That's kind of at NAT5 level. There isn't much lies you get told at NAT5 in this course, but this is one of them, whereas really cache is faster than registers, and then it's RAM or your main memory. So this is fastest just because it's built onto the computer, and the way it works is that the processor, before it even checks RAM or anything, it will check the cache memory. It will check to see if the data is already there. And I've talked about this before. The type of things that are stored on cache memory are, if you go to one website constantly, if you go to YouTube constantly, right? You'll notice when you boot up YouTube, it might work sometimes that the background, like the layout of YouTube, will load up quicker than the actual content on the site, and that's because your computers recognize you visit that site so much that the CSS of the site is stored on your computer, and then it will have a look for the cache. It will have a look in cache to see if it can find that CSS, and then it doesn't have to load it from RAM. It's already stored there. Now, there's actually 3 levels. It will check the first level first, and then if it can't find that, it's called a cache miss. And then it will check the second, then and if that misses, it will check the third and that. The first one is like extremely fast, and this is slightly slower, and this is slightly slower. But obviously, all 3 of them are still faster than RAM. But you just need to know that it's slight variations in speed. And again, if this came up in an exam, you would say something like, using cache memory instead of RAM, or trying to access cache memory instead of RAM, would increase the performance of the computer. And that is it, really. So just in summary, because I know I kind of jumped across a lot of different things here, the 4 main things you need to take from this are how the number of processor cores affects a system's performance. So generally speaking, the more processor cores you have, the better your computer is, like performance-wise. Clock speed. So again, the larger the clock speed, the better performance you're going to have. The larger the data bus, the better the performance you're going to have. And using cache memory is also going to increase performance. Now, along with that, there are, except from this one has no disadvantages, there are a few disadvantages with these three you need to be aware of. So you might want to go back over the PowerPoint and make sure you know what the disadvantages are, because I did admittedly storm through this. All that's left to say really is there is a task. It's only 10 questions, they're all multiple choice again. Make sure you click the view results button after submitting it and it'll tell you your answers instantly. I had a few people asking me for their scores, but they are there instantly. And I've also put, at least for it doesn't let me do it for the short answer ones, but for the multiple choice, I've put up like comments to say how you got it wrong and why you might have thought that and what the right answer is. I've also put this up because apparently the link wasn't working for some people, but a QR code works. I don't know if that's necessary again, but it's there if you need it. Right, if there is any other things you need help with, because this is really important going forward, please drop me an email or write on the Teams or anything. Right, thank you, bye.